Thank you so much, Jason, for this perfect introduction. And hi, all, Bojan here, product manager for Microsoft Defender for Cloud on the customer experience engineering team here at Microsoft. Really glad to be joining you today to share some information which might be of real value when thinking about how to protect your multi-cloud environments. As you can see, the topic of my presentation today is really all about Microsoft Defender for Cloud's multi-cloud capabilities and how you can use them to protect your multi-cloud environments. What I thought I would do today is start by spending a little bit of time talking about multi-cloud security all up to give us that foundational understanding around some challenges, but also some trends that we are seeing in the market today and how that's applicable to multi-cloud environments. Then I'd like to share with you how Defender for Cloud can help address these challenges. And here I'd like to spend a little bit more time discussing Defender for Cloud's native support for AWS and GCP, and to really kind of dig deeper into what does that include. Finally, I want to give you a glimpse of how do the multi-cloud capabilities inside of Defender for Cloud look like and how you can also enable them for a live demo. There, I want to touch briefly on some new product enhancements which we released all inside of a full-fledged live environment. And as Jason pointed out, I'm really keen on hearing from all of you here today. And I want to end after the demo on a high note with Q&A. Should you have any questions throughout the presentation, I want to again invite you to use the chat window and put your questions and type them in there. I'll make sure to circle back to them at the end of this session. There are also other folks on the call standing by to answer your questions in the chat window, and I'd like to also thank all of them for joining us today to help with your questions. So that's in a nutshell our agenda for today. Now, before going into multi-cloud security and sharing with you what are some trends that I'm observing and what are some challenges that we as a wider team are seeing, I always think it's best to put myself in the shoes of the audience. So the challenges that I'm looking to also address today to make those easier to understand, but also to make Defender for Cloud multi-cloud capabilities easier to understand, I brought an example with me. I brought an example of an organization that has a multi-cloud environment and is looking to secure it. This company is called Contoso, and chances are you might have already heard about Contoso, as it's the name of a fictitious organization that Microsoft uses as a customer example. Now, as you can see, Contosys' cloud environment spans more than one public cloud provider. In fact, it spans three public cloud providers, where a significant amount of their code and the way that they go about developing applications is dependent on third parties. And the challenges that Contoso is experiencing are very, very similar to the challenges shared by many other organizations too. So here I just want to touch briefly on the top three. The Some of the challenges, but also trends that we are seeing is just how important it is to develop and operate secure applications in the cloud, as it can also span multiple public cloud providers, thereby increasing the organization's attack surface. What we're also seeing specifically to organizations that are embracing a multi-cloud strategy, like Contoso here, is that it puts an added emphasis on adhering to security best practice guidance across different public cloud providers whose technical implementation might differ. They also adhere not just to security best practices across public clouds, but also across specific industries, while at the same time trying to get a handle on managing their multi-cloud environments and its complexity. Now, this can also include regulatory compliance standards that organizations need to adhere to, all while the tactics, techniques, and procedures of attackers, or TTPs as they're commonly referred to in the cybersecurity industry, continue to evolve. This means that the techniques, and procedures that attackers are using today might differ from the TTPs that they're going to be using in a week from now or even tomorrow. And what we're seeing here are really two trends, both of which are alarming. The increase in number of attacks, but also the increase in the sophistication. So I want to also acknowledge that addressing these challenges, it is a journey. And the way to look at each one of these could be by breaking it down into specific functionalities and capabilities aimed to address. Because I also touched upon the attacker's TTPs, one way to look at this is in the form of a kill chain model, where you need to then secure different types of cloud resources across not just different public cloud providers, but even different stages, ranging from exposure of resources to insecure configurations, potentially known vulnerabilities or unknown, but also exposed credentials. Any of which really of these could lead to attackers gaining access to the environment, to the different resources that you have across public cloud providers, and even moving laterally and performing malicious actions such as ransomware and data exfiltration. To make this more palpable, I'll go back to Contoso. And to give you a sense of how an example might unfold, going back to Contoso using more than one public cloud provider and also leveraging a lot of open source technologies. In the first example, we see how the open source tool, which is used for monitoring, if it has a vulnerability, it could be used to allow remote access. This in turn would allow attackers to then land inside of the environment and also start looking around, seeing what else can they discover here. So they could execute internal reconnaissance to then discover other types of resources, even on other public cloud providers, like an AWS RDS instance. The attacker could then manage to access the RDS from a command shell and to gain admin permissions and even create using those a snapshot of data and drop it into Internet Exposed S3 bucket. This in turn would now allow the attacker to read the snapshot from the side, so meaning it would be then publicly accessible even without needing to authenticate to gain access to that snapshot. Now, this is just one example. The second one is going back to the open source artifact that can be pulled into a container registry as part of a build process. This artifact then in turn could include vulnerabilities that later on an attacker might use to invoke something along the lines of a crypto miner already in production, which could not just result in high compute shock and cause, but we also seen that in the past, crypto miners were also an effective way of delivering and facilitating ransomware attacks. Now, these two examples are by no means meant to be the top of the list or to be the definite list, as unfortunately there are many, many more. In fact, if I was to go through all the different permutations, we would exceed even the time that we have on our call today. But I do believe they give a good sense of what are some challenges that organizations who are pursuing a multi-cloud strategy are facing when it comes to ensuring that they break this kind of an attack path across multiple public cloud providers, and also some of the trends that we're seeing in the market. So what I wouldn't be here today if I didn't knew that Defender for Cloud can help address these challenges. But Defender for Cloud can do much more, especially while companies are embracing multi-cloud strategies. We definitely see a need to have a tool in place which can unify not just the detection of misconfigurations and providing best practice guidance on how to remediate those, but also that can centralize DevSecOps security management, regardless where the resources are deployed, be it in Azure, be it in GCP, AWS, or potentially on-prem. In addition to these two pillars of capabilities, we know it's equally important to monitor in the environment for potential signs of compromise across different resource types, and as mentioned, even across the different stages of the kill chain model. followed by then responding to remediate to these threats to the environment in a more proactive and programmatic manner, for which you could also use something along the lines of workflow automation. Now, I'd love nothing more than to cover each one of these boxes you see on the slide in more detail, but the truth is we simply don't have enough time to do so today. And when I asked myself which one of these boxes I wanted to prioritize for our conversation today, I wanted to show you how you can gain that end-to-end visibility, which is why I also look forward to sharing and clarifying a little bit further about how you can onboard your AWS and GCP environments to Defender for Cloud. Again, providing you with that end-to-end visibility across multiple public cloud providers. Then I also want to use that onboarding to show you how Defender for Cloud can then continuously assess, monitor your cloud resources, regardless where they reside, be it in Azure, GCP, or AWS. Then I also want to touch on the threat detection capabilities, historically referred to as cloud workload protection. There, I also want to show you what are the built-in and native functionalities that we have for cloud resources in GCP as well as in AWS. Lastly, I also want to then end on a high note and see what other questions you have for me. But I also thought it would be wise to share with you as I go about covering each one of these capabilities. What are some also more recent product enhancements that we've introduced? There, I'm talking particularly about the option to also onboard your AWS and GCP environment using Terraform, which is something that a lot of organizations have been asking us to support, and we do support. So I also want to cover those. As you can see, this conversation is even much wider than that. And I would encourage you to tune in into the other webinars that we're going to be having in this series, who are, if not already, have covered the other boxes in even more detail. But now going into how you can use Defender for Cloud to strengthen your security posture across public cloud providers, I want to touch on two core notions here, referred to as foundational CSPM and Defender CSPM. Historically, Defender for Cloud was always this tool that could have provided you with visibility of your cloud resources, detect misconfigurations continuously, and also provide you with security best practice guidance on how to remediate those resources. Can I offer an example? Imagine if you have VMs in AWS, in Azure, and in GCP. Imagine if you're interested in understanding how to detect misconfigurations and implement security best practice guidance. You can use the foundational CSPM tier in Defender for Cloud to accomplish this scenario. The foundational tier provides you with continuous assessment of your resources, regardless where they reside, be it in Azure, be it in AWS, or be it in GCP. The foundational CSPM is available for free, meaning you can use it even across clouds, and it provides you with a list of recommendations that you can use to harden your AWS, Azure, and GCP resources, all at no additional cost. There, still in the foundational CSPM tier, you can look to leverage capabilities such as Secure Score that provides you with a security KPI, even for clouds such as AWS, GCP, and Azure, but also all up, as well as the other capabilities that are listed here. Now, you might be asking yourself, why is there then also Defender CSPM listed here if you can get all of that with foundational CSPM? And I'd like to offer a perspective. We are living in a time where there is an emphasis to do more with less. That for me also implies prioritization. Defender CSPM provides you with a set of premium and advanced CSPM capabilities that you can use to prioritize the misconfigurations that Defender for Cloud has detected across your multi-cloud environment. Again, imagine if, going back to the previous example, you had VMs in Azure, in AWS, and in GCP. With foundational CSPM, you can be notified of all the misconfigurations on your VMs across your multi-cloud environment. With Defender CSPM, you can go not just one, but more steps further. With Defender CSPM, you can Defender for Cloud will provide you with a way to understand what attack paths, like the ones that I mentioned about Contoso, if you remember the open source tool, which could be used to infiltrate the environment, spread laterally, and exfiltrate data by an RDS AWS snapshot hosted on a S3 bucket. So Defender for Cloud would be able to, in a similar way, to alarm you of such a potential attack paths. But in addition, it would be able to take all of those misconfigurations that were focused and provide you with the prioritization, for which you could use either attack paths, or you can tap into that data directly through something referred to as the Cloud Security Explorer and write your own queries even across clouds. Now, Defender for CSPM does have many capabilities. At a very high level, you see those highlighted here. But I will also in the demo go a little bit further into giving you a sense of how does this look like. But before I do that, I just again wanted to emphasize that you can still use Defender for Cloud's free foundational CSPM tier across Azure, AWS, and GCP for free, and it will provide you, as you can see here, more than 450 out-of-the-box recommendations. So this means it can continuously detect the misconfigurations in your multi-cloud environment at no additional cost. If you, however, then require more advanced capabilities that allow you to prioritize those misconfigurations, such as the one that you see on this slide here, where you're able to see not just the misconfigurations of the resources, but more importantly, its context, then you would need Defender CSPM. So going back to the previous example, if out of those VMs that you have in Azure, AWS, and GCP, if you wanted to understand which 10 VMs you needed to remediate first, because those could be used by attackers to gain access to your environment, then Defender for CSPM's capabilities could help out with that. Now, to show you how this looks like, I want to switch gears and I want to move into a full-fledged demo environment from a colleague which was kind enough to already have it hydrated, so I can give you a sense of how this looks like inside of Defender for Cloud. So let me go ahead then and share the demo environment in question. If the team is not able to see the demo environment at any point in time, I'll just appreciate if someone could come on mic and let me know. Otherwise, I'll continue. Now, what I want to give you an overview of are the capabilities that we spoke about. So I'll cover onboarding later on, but after you've connected both your AWS and GCP environment to Defender for Cloud, as I've done here, you can navigate to the Microsoft Defender for Cloud dashboard and click Security Posture. This dashboard provides you with an overview across your clouds and across your multi-cloud environment spanning Azure, AWS, and GCP, where you even have these quantifications, or some might even call them a singular security KPI for each cloud that comes in the form of Secure Score. So because Defender for Cloud is able to continuously assess my environment, my AWS and my GCP resources, it's also able to quantify from a security posture perspective how much strengthened is my environment here. So the maximum is 100%. So I see that I have a long way to go when it comes to adhering that my resources in AWS, GCP, but also in Azure are hardened, meaning that they adhere to security best practice guidance and that they don't have any misconfigurations. All of this is available for free, and it is part of foundational CSPM, not just for Azure, but also for AWS and GCP. Furthermore, I can see here then also a breakdown per individual projects, Azure subscription, and even AWS accounts. Now, if I click recommendations, here is where I'm able to then see those misconfigurations that Defender for Cloud has picked up on. I can be as granular as to single it out for a specific cloud provider such as GCP or AWS, or in this case, I can have all three enabled as you see here, providing me again with that end-to-end visibility of my multi-cloud environment, all inside of one single dashboard named with Defender for Cloud. Now, all of that I've shown you so far is available for free, and you can use it to improve the security posture of your multi-cloud environment. And as mentioned, I'll cover onboarding to teach you how to do that in a bit. Now, we are committed to helping organizations do more with less. And although the foundational CSPM provides me with this list of recommendations, especially for large environments, this might be a lot of misconfigurations to remediate. Have you ever found yourself in a situation where you wanted to understand which out of these misconfigurations should you prioritize? This is where one of the Defender CSPM capabilities that I spoke about can help. And if I go to attack paths, I can then see what does Microsoft and what does Defender for Cloud suggest I prioritize out of all of these misconfigurations that Defender for Cloud has detected. I can even filter it based on a specific environment such as AWS, where you see here Defender for Cloud is suggesting I tackle the misconfigurations listed in these attack paths first. To give you a sense of what is an attack path and how does it look like for multi-cloud resources, I'm going to select the one that you see here. Internet exposed EC2 instances can have high severity vulnerabilities and read permissions to a key management service. Now, attack paths can be more complex or less complex. This is an example of a somewhat of a complex attack path, where if you think of the example that I shared that Contoso can face, where an open source tool can be used to gain entry, unauthorized entry to the environment, and then the attacker could use it to wreak havoc there. So this could be a close example where you see that through internet exposure, and you can even see here the IP address, which also integrates with Microsoft's Defender for External Attack Surface Management solution, where if I, for example, have this solution, I can even go click this link, and it's going to provide me even more details in Microsoft Defender for External Attack Surface Management. However, even if I don't have this specific Microsoft solution, I'm still able to see these insights related to the IP address, for which I see, and then through an AWS EC2 network interface, the attacker could get access to an AWS EC2 instance. And this EC2 instance in question, if I see here, I can have more information about the high severity vulnerabilities that it's susceptible to. Now, this matters because these vulnerabilities could then be used for an attacker to move laterally inside of the AWS account and to even access other AWS resources, such as, for example, this key management service that you see right here. So all of this I have in this graphical representation of what's referred to as an attack path. And it allows me then to also prioritize the remediation of misconfigurations for my multi-cloud resources, because I see there are more than one attack path here. So I see for this same, if I can call it such, scenario, which is an attack path, I have many, many more resources that are affected. So by switching over to recommendations, I see that I can see which recommendation, if I remediate, could help me to break or to close off this attack path and to minimize the chances for the attacker to find success with their attacks in my environment. And in this case is to remediate that EC2 instances should not have a public IP address. Now, when it comes to remediating resources, by working with organizations, we understood that this is a team sport. So this is really a joint effort where a lot of times the person who manages Defender or operates Defender for Cloud needs to work hand in hand and in partnership with the workload owners who own these specific resources, be it in AWS, GCP, or Azure, and potentially even on-prem, which is why here, when I go about ensuring that these resources are remediated, what I can also do is assign an owner to them. Assigning an owner as well as setting a due date that you can see here will help drive the remediation by ensuring accountability. Because if, for example, I go here and I say for this particular one, this is my resource. So I want to ensure that I'm on point for remediation and the realistic time frame to do this, I'm going to say until end of this month. Now I can also ensure that if I don't want secure score to be negatively affected, I can apply the grace period. You might be asking yourself, why have a hero grace period? Have you ever found yourself in a situation where after patch Tuesday, you see secure score go down because Defender for Cloud has detected vulnerabilities in your virtual machines or your compute resources? By applying a grace period, I'm able in this scenario to also ensure that I don't see any volatility in secure score and for it not to see my campaign catch up with secure score going down after patch Tuesday. So in this case, I want to ensure that I'm leaving grace period disabled and I'll leave the default settings as they are, where through an integration with Azure Active Directory, I'm also able to leverage that the owners are notified of any open on overdue items that they have, as well as the integration with their direct management so they can have that visibility as well. So doing this, I can click save and I can assign a task to myself. Now, I'm not the owner for this particular resource, so I'll go ahead and I'll leave that. But what I wanted to share with all of you is going back that you can, after you onboard your AWS and GCP environment to Defender for Cloud, you're able to, even for free, get a list of misconfigurations that you can see in your multi-cloud environment. Then you could look to enable Defender CSPM, which I'll cover shortly, for your AWS and GCP resources to help you understand which misconfigurations you should look to prioritize. Now, this can come in the form of attack paths that you see here, which you can also then filter for a specific environment. The example that we looked was this one here, as well as then the recommendations that you need to remediate to ensure that this attack path is closed off. And you can ensure accountability and ensure a faster remediation process of those misconfigurations by assigning owners. And obviously, you do not need to do this manually. You can also do this programmatically using a capability which we have. Now, with that, I want to go back to the deck because there are a couple of other things that I want to share with all of you. We spoke about Defender CSPM and having a sound security posture by ensuring that the multi-cloud resources adhere to best practice guidance. However, we all know that it's equally important to after best practice guidances have been implemented to ensure that the environment is actively monitored for potential signs of compromise. So imagine if after you've remediated misconfigurations, you want to ensure that if there is any kind of an active and suspicious activity on your resources for you to be alarmed and for you to be notified. For this, you can leverage the threat detection capabilities available inside of Defender for Cloud, which also span public cloud providers, meaning you can use them not just for Azure, but we also have native support for AWS as well as GCP, in addition to on-prem support as well. And these capabilities are important because they also not just use a couple of different and ways to correlate threats and detect them. But they also do something which a lot of organizations considers to be valuable, and that is the integration with the MITRE ATT&CK framework. MITRE ATT&CK is one of the leading nonprofits that aims to distill knowledge of attackers and cyber adversaries into their framework, which by providing a mapping to, we're able to help organizations understand the effect that those alerts as well as misconfigurations have against a particular attacker's attack lifecycle, like the ones I previously mentioned to you. Now, the way you go about enabling this capability is very, very much tied to the way you go about enabling the capabilities that strengthen your security posture for AWS and GCP. And for sake of time, I want to join these two together with a specific emphasis on the native GCP and AWS support. There is still a preconception and a myth, which is untrue, that our capabilities require an agent. And that is dependent on which capabilities we're referring to. I want to share with all of you that our CSPM capabilities, be it for Azure, be it for AWS, be it for GCP, are completely agentless. So imagine if you wanted to get vulnerability assessment findings for your virtual machines running inside of Azure, AWS, and GCP. To accomplish this scenario, you can use Defender for Cloud's native CSPM for AWS and GCP, in addition to the one in Azure, which would allow you in an agentless manner, so without deploying any agents, to get insights of vulnerabilities in your VMs across these three public cloud providers. If you were looking to enable the threat detection capabilities, those do leverage Azure Arc, and Azure Arc is a proven service inside of Azure that's able to provide you with also management capabilities of, for example, your servers outside of Azure. To give you a sense of how this looks like, I want to go back to the demo environment and give you a first-hand glimpse into how you can use the new onboarding experience that we have to onboard both your AWS as well as your GCP environment to Defender for Cloud. To do so, I'm going to switch to a slightly different demo environment than the one I was sharing before. And the reason for that is I also want to here show you how you can connect this using the necessary permissions that I have in my tenant. So would appreciate if the team could let me know if they're not able to see the demo environment. Unless someone comes off mic, I'll just assume that they're able to see it and go ahead. Now, the way I onboard my GCP and AWS environment is by navigating to the Defender for Cloud dashboard and selecting environment settings. Here, I'm presented already with an overview of which Azure subscriptions and as well as management groups have been onboarded to Defender for Cloud, but also which GCP organizations or projects, as well as AWS management accounts and single accounts have been onboarded to Defender for Cloud, providing with a single view of the environments that I've onboarded to Defender for Cloud. Now, firstly, I want to start with giving you a sense of how this works for GCP. So I'm going to go select Add Environment and click Google Cloud Platform. Here, I need to provide a name to the connector, which is going to store the configuration preferences of this click-through wizard that you're seeing here. So this can be something like GCP Contoso, and here I can select if I would like to onboard at scale. So if I would like to onboard at the GCP organizational level, or if I would like to onboard a single project. Imagine if you wanted to onboard all of your GCP environment to Defender for Cloud to leverage the agentless vulnerability assessment capabilities. There, you would need to select then organization. You would need to input a name for this security connector. You would need to select the Azure subscription as well as the resource group in which this security connector is going to be stored on the Azure side, as well as the location. Then you will need to provide the organizational ID. However, in my case, I'm just going to use a GCP project instead, where I'm going to need to provide the GCP project number, and I'll copy that across, as well as the GCP project ID. After I have those, I'm going to click Next. Here, I can make a selection of the different Defender for Cloud plans that I'd like to enable. Foundational CSPM is available at no additional cost, and it's already enabled by default because it's also the prerequisite for the threat detection capabilities that you see here. So we also support native threat detection for GCP when it comes to servers, to databases, and to containers. And I can enable all of these as you can see here. Then I can click Next. Now you see here these two options where it says permission type. You see default access and least privilege access. What do you think those are about? Have you ever found yourself in a situation where you wanted to, when you onboard your GCP or AWS environment to Defender for Cloud, to ensure that Defender for Cloud has permissions only to the resources that you currently and plans that you currently have enabled? If so, you can accomplish this scenario by selecting least privilege. Least privilege is a relatively new addition to our onboarding experience, and it will ensure that when you onboard your GCP or AWS environment to Defender for Cloud, that the permissions you are providing with Defender for Cloud, that you're providing to, apologies, Defender for Cloud on the native public cloud provider side. So be it either on AWS or GCP, by selecting least privilege access, you ensure that Defender for Cloud has only the permissions for the plans and functionalities that are currently available. So available as of the day or time when you do the onboarding. Now imagine if new capabilities come available that require other permissions, ones that are in addition to the least privilege access that you've selected. So you can be notified of these and you will, allowing you also then to update these permissions. Now, if you select default access ensures that, imagine if you wanted to ensure whenever there is a new functionality provided by Defender for Cloud for AWS or GCP, that it is able to have the necessary permissions to provide you with those capabilities. So you could do this by selecting default access. Now, when you go about deciding how you want to onboard, here is where we also recently introduced additional flexibility. You can use the native public cloud providers native way, which in case of GCP is using the Cloud Shell script, which you can copy across. You can run it inside of the Google Shell here inside of Google Shell, and it's gonna create the identity federation as well as the roles that are required for Defender for Cloud to provide you with security value, some of which you can see here, such as CSPM, Defender for Servers, for example, Defender for Containers, etc. So this is the public cloud provider's native way of onboarding, which you can do when you select this option here, GCP Cloud Shell. However, have you ever found yourself in a situation where you wanted to onboard using Terraform? Well, now you can also do that with Defender for Cloud. Terraform is an infrastructure as code or ISC tool you can use to build, change, and as well as version your public cloud infrastructure safely and efficiently. A big advantage of using Terraform is that it's a widely used tool, and it allows you to automate the onboarding process and integrate it into your existing processes that you have and are using. So Defender for Cloud provides you with more than one option of onboarding AWS and GCP environments. So in addition to using the public clouds provider's native approach, which in case of GCP is the Cloud Shell, you can also use Terraform here as well. The way you go about then using Terraform is, and apologies for these fields being obfuscated because I'm using here the Azure Moss plugin, you would need to based on the selection you did in step number 1 and step number 2, Defender for Cloud is going to generate this Terraform template for you, which is going to come pre-populated with the parameters that you require to onboard your GCP environment to Defender for Cloud with Terraform. So as a first step, you will need to either copy this across and then save it, or just download this Terraform template locally. After you've downloaded the Terraform template, there's also going to be one other prerequisite, which is going to be you would need to log in into the Google CLI using the command prompt, like the one that I'm sharing here. So the first step after you've logged into the Google CLI using command prompt would be to download the Terraform template from Defender for Cloud. So you would need to then enter Terraform in it, and this would essentially prepare Terraform for what's going to take place next. What's going to take place next is, as you can see here, I already have the commands saved, so I'm just going quickly through them. And as a pro tip, when I do this, I save the Terraform template as main.tf, which allows me then to out of the box use the commands which are highlighted by Defender for Cloud. The second one, which is the one you see on screen here. And this is going to generate the Terraform execution plan for me, which I require because this is going to do the necessary series of checks to ensure that I can onboard my GCP environment successfully. And after I've done so, then I can do the last step, which is, and I can even show you here because I already did it, but then I can use the last step, which is to ensure that the changes are applied by typing in Terraform, followed by apply tf.plan. And when I click enter here, that is going to ensure then that Defender for Cloud is going and creating, as mentioned, the necessary roles and the identity provider it needs on the GCP side to ensure it can provide me with the security value I selected, be it foundational CSPM, which is free, or be it the threat detection capabilities or the other plans that you saw covered. Now, after I've done this, I need to go back into the demo environment I was sharing. So I'm going to quickly do that. And after Terraform finishes successfully, I'm going to go here, click next, and hit create. I'm not going to do that here because I actually already did that. And as you can see, it's already created for the GCP project I was looking to onboard. While we're here, I also want to draw your attention to something else. Do you see here project name Fabricam? Do you know how this is called on the GCP side? So let me switch over to my Google Cloud Shell or Google Cloud Console, apologies. So when working with projects, we also learn from organizations that they would appreciate if we also supported the alias, which is used on the GCP side, which is why in addition to the project number and the project ID, Defender for Cloud also does support the alias as well, which is the one I have here, project name Fabricam, which is also the one that's represented in the Defender for Cloud dashboard. Now, this is how you can onboard your environment to Defender for Cloud, be it using Terraform. With Google Cloud Shell, it functions very, very similarly, where I'm gonna select Google Cloud Platform. I'm again gonna input not this one, I'm gonna input the name for the connector, which is gonna be used, and I can select either the organization or a single project. If I go ahead and just select a single project, I need to again select the similar to onboarding with Terraform, the subscription and the resource group, as well as the location in which this security connector is going to reside, then followed by the project number and the project ID. After I selected the plans that I would like to see enabled, or in a way, the security value I would like for Defender for Cloud to provide me with for my GCP environment, I can click next. So here you can see that regardless if you choose to onboard via Terraform or Google Cloud Shell, the first two steps are exactly the same. The first step is where you really can have that additional flexibility on whether you would like for Defender for Cloud to have least privilege access, as well as what would you like to onboard rather, the native clouds preferred approach or Terraform. With Terraform, you can use one tool to onboard both AWS and GCP. With Google Cloud Shell, you can obviously use native's a GCP approach, and both of which we provide here. Just also be on the lookout for that once you make a selection, be it Cloud Shell or Terraform, this section is also going to change. Then you would need to either run the GCP Cloud Shell template or onboard via Terraform like I showed you. And after that has finished successfully, you can go ahead and click Next and click Create here. This is going to ensure that your environment is onboarded to Defender for Cloud. This is important because you can get real value then inside of the Defender for Cloud dashboard inside of 24 hours, where you are then able to, through the security posture, to have end-to-end visibility of your environment, multi-cloud environment across Azure, AWS, and GCP inside of a single dashboard that is Defender for Cloud, and use it to continuously assess your workloads, be it in the recommendations blade, or prioritize the misconfigurations based on context and based on misconfigurations attackers could use to not just breach, but also move laterally and exploit and export data, attack path analysis, as well as the other Defender CSPM capabilities. Now, being mindful of time, I want to also cover how does the onboarding for AWS work. And I'm going to go ahead, select Add Environment, and select Amazon Web Services. As you can see, the onboarding for AWS is very similar to the onboarding for GCP as well, where I need to name the connector, which is going to save the security, which is going to save, apologies, the configuration preferences of this selection I'm making during onboarding that resides into a specific Azure subscription on my side and a specific resource group. And here I just need to input the AWS account ID. However, depending on when you started your Defender for Cloud journey, it might be that you see something which might be new, and that is this selection of AWS regions, which by default, all regions are selected. However, have you ever found yourself in a situation where your organization, due to whatever reason, does not allow deploying of resources into specific AWS regions? If so, here you can then tailor to which regions Defender for Cloud is going to be making calls, API calls, as well as do the scanning and the continuous assessment and monitoring. So regions are a very, very powerful way that you can be very, very succinct in a sense. If I, for example, have an organizational-wide policy that I'm only able to use US West, East in this case, as well as Europe, which is based out of Ireland, to deploy resources, then I know in the other AWS regions, I don't have any resources, so I can go ahead here and tailor that Defender for Cloud is only going to be continuously assessing and monitoring the resources in these two regions. Why does this matter? So imagine if I was using something like CloudTrail, which is then going to be logging any even call that Defender for Cloud's APIs make. So this could be also a very, very prudent way for me to ensure that I manage the API, the CloudTrail logs, which are also paid. Then I can go ahead and select the plans. Foundational CSPM is available at no additional cost. This is going to provide me with the recommendations from AWS resources. Defender CSPM is a paid plan, and I can even see here the price. I can use the built-in even ability to provide me with a price point called the cost estimation workbook, and I can even here then enable the additional threat detection capabilities for AWS. And similar to GCP, I can even use least privilege if I needed to, and even onboard using Terraform following this very, very similar instructions like for GCP. The main difference being that obviously I would then need to first authenticate to the AWS CLI and not to the GCP CLI. But all of this would then allow me to streamline the way I go about not just onboarding Defender for Cloud, onboarding GCP and AWS, apologies, to Defender for Cloud, but the way I go about also operationalizing Defender for Cloud for my multi-cloud environment. So with that, I'll switch over to the slide deck to cover a couple of additional resources that I'd like to leave you with. There's a communities like this make more possible, and we have a vibrant Defender for Cloud community, be it by publishing technical articles and really deep dive scenarios on specific either customer pain points or something we see organizations struggling, which is what you can see in the tech communities articles, as well as the Defender for Cloud in the field video series hosted by our Yuri, who is always up to date on the latest and greatest coming into Defender for Cloud and helping demystify those. Obviously, in addition to the various other helpful resources, be the documentation, where you can also find, again, just for your reference, the necessary permissions that are required to perform the actions I showed you today, but also the various other collateral that we have here. Now, I do want to make sure, looking at the clock, that at the least answer and have time to answer a couple of questions. So let me go back to the chat window to see if the team has any questions for me.
Great, thanks, Bojan. The team's been great with answering questions. We do have a few that might be worth reiterating. The first one is, the AWS connector leverages Security Hub, or does it not? To be specific, in order to implement a multi-cloud CSPM solution via Defender for Cloud, am I obliged to enable Security Hub in my AWS accounts?
I believe that's a really good question, because just to kind of also expand the question, if you allow me, Security Hub is a paid service on AWS. And if you're using a paid service, then obviously there is a price point to consider. I want to emphasize that you do not need to enable Security Hub if you're using Defender for Cloud for your AWS environment. So if you remember when I spoke about foundational CSPM being in Defender for Cloud free, not just for AWS, but also for GCP and Azure, this means for your AWS environment, you do not need to enable Security Hub, and still Defender for Cloud in an agentless manner is going to be able, inside of a single dashboard, to provide you with insights and detect misconfigurations for your AWS resources. So that's the long answer. The short answer is no.
Great, thank you. The next question we have is a grace period the same as giving an exception?
I love that one. The short answer is no, they differ. The exception would be, imagine if I, for example, found that what Defender for Cloud was detecting was not applicable to my environment. An example might be if I already internally agreed that this is an acceptable risk because we're running an application which is quite mature, not to say old, then it has something that we already signed off as potential risk. So in that case, I could then exempt the resources which Defender for Cloud has detected misconfigurations on. Grace period differs though, because with grace period, what I'm saying is I'm in a way acknowledging that it takes time to remediate resources. So with a grace period, I can say, if you go back to the example I gave, imagine if after Patch Tuesday. So I'm not going to go ahead and exempt all of my VMs after Patch Tuesday. That really wouldn't be wise or prudent. What I can do, however, with the grace period, I can in a way acknowledge that my team needs a certain amount of time until they go about patching all of the VMs on which Defender for Cloud has detected misconfigurations. And that time can then be expressed with grace period. Both great questions, though. What other questions does the team have for me, Jason?
Great, yeah. The next question we have is, how will we push Arc Agent to AWS and GCP?
I should also express my gratitude. Apologies, I don't see who asked that question, but this is one of the things, unfortunately, due to the limited time that we have today, that I wasn't able to cover, because you're able, as when you go about creating the security connector, which is the way, if you recall, that you onboard your AWS environment that I showed. As part of that onboarding process, you can, by enabling the threat detection capabilities, you can also auto-provision the Azure Arc agent. There are, however, for example, for AWS, there are specific prerequisites, which you can also find in the official documentation. For example, the EC2 instances, if we're going to consider those, need to have the SSM agent installed, and the SSM agent is something we're going to then use to push Azure Arc to those EC2 instances, and for Azure Arc also other extensions such as, for example, Microsoft Defender for Endpoint extension that we use to provide you with even more security value inside of Defender for Servers. So that's the long answer. The short answer is Azure Arc is going to be automatically auto-provisioned when you go about onboarding your AWS environment if you selected the threat detection capabilities. Again, the CSPM capabilities are completely agentless and they do not require Azure Arc.
Great. Oh, thank you, Bojan. I think that's all the time we've got for questions. So with that, I'd like to thank Bojan for being our guest today and for sharing the great information with our community. Also, thank you to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about the upcoming webinars, events, and other announcements. Also, please take a minute submitting your webinar feedback at aka.ms/security-webinar-feedback. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/mdccommunity. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.